What's up, team? Today we're talking about applying congruence criteria. So we're going to be doing some proofs. That's the game plan. This video, I'm going to walk you through two different proofs that hopefully help us feel a little bit more comfortable using these ideas here. Our learning target says, I can prove that two triangles are congruent using the triangle congruence criteria. Now, I want to have a real short discussion regarding proving the triangle congruence criteria, the side, angle, side, all that stuff. The good ones are up here: side, angle, angle, side, or side, angle, and the bad ones here are angle, side, angle, or angle, side. If you don't know what that means, please watch the previous video. I explain it. So I want to have a real short discussion regarding how do we know that these ones are good and these ones are bad. I'm not in a position to walk you through a real formal proof of all these. They're just a little bit more complicated than what we're prepared for, but I can walk you through a fairly informal proof. So I'm going to go ahead and do that. I'm going to share my D's screen with you and show you what I'm talking about here. So I have two triangles here. I have a red triangle, I have blue triangle. This triangle here is ABC, the red one. The blue one is DEF. We know a few things about these triangles. We know that this leg here, BC, is 3.16 units. We know that AC is 4 units, and BCA is 72 degrees. We see similar things are true down here. 3.16 is this side is 4, this angle here is 72 degrees. But we don't know anything else. We only know those three facts about each of these. Well, if we look at our triangle congruence criteria that's on the board, here, let's bring you back on the board over here. We can see that side, angle, side is one of the good ones. That one passes. And what we have with ours is indeed side, angle, side. We have a side, an angle, and another side. And it's true on both of these potentially congruent triangles. So the way that we can show using software like this pretty quick and easily that these two triangles are congruent is if we can perform any rigid motion, do some transformation that is rigid, that maps one of these onto the other one, then we can definitely determine that these two triangles are congruent. Because recall that a rigid transformation does not change the size or the shape. So I set myself up to give me an easy one here. I'm just going to do a translation, and I'm going to move it from point A to point D, and you'll see pretty quickly when we move triangle ABC onto DEF, this one is going to map right on top of the other, or the image of this one, the transformation is going to map right on top of this. And you'll notice that because this blue will turn into kind of a purpley colored, purple-ish. Boom, there we go. So now there's the image of the red triangle on top of the blue one, and you can see that they match one another perfectly. This is, like I said, is a super informal proof, but at the same time, I'm hopeful that it convinces you a bit that you could do the same thing with any of these criteria, and you have been demonstrated, at least to some degree, for very specific cases. You could do it for every case. That's certainly not an exhaustive proof, but all of these work if you were to use any of these criteria and follow any same method here. Okay, before we do a proof, let's recall what our goals are for this proof, or I guess let's figure out what our goals are for this proof. Our goal, we need to choose which criterion to use. Are we going to use side? Are we going to use side, angle, angle, or are we going to use angle, side? That decision needs to be made before you even start doing your proof. So with that, you're going to look at your picture, try to figure out what you know, what you can figure out, and then determine like, oh, hey, this one is side. And then you can start to write up your proof. But make sure you know what your destination is before you even get started. And then when you're doing your proof, your goal, after you've decided which of the criterion you're going to use, is to prove that all three corresponding parts are congruent. Meaning, if you chose side, show that the three corresponding sides are congruent to one another. If you choose side, angle, side, show that the two sides, corresponding sides are congruent and their included angle are congruent to one another. So whatever one you pick, well, obviously, sometimes there's more than one that works. Generally, there's only one that works. So you have to pick the right one and then show that all the pieces are indeed congruent to one another. All right, here's our first proof. We have this big triangle, J, K, L, and then we have this line down the middle, LX, and then we have some given information. So before we even look at this, so forget that's even there. I shouldn't have even drawn it up there yet. We're just going to look at the given information. We're going to look at our picture. We're going to analyze this. We're going to see what we can see, and then we'll make a game plan, and then we'll start putting things over there. So we're given that x is the midpoint of jk. Pause, stop right there. Let's figure out what we can, like, how can we use that information? If x is the midpoint of jk, well, we know by the definition of midpoints that x then chops this segment jk in half. Therefore, jx and xk must be congruent to one another. That's huge. We all of a sudden, we already have one pair of corresponding sides that are congruent. That's great. What else do we know? JL is congruent to KL. Okay, JL is up here and KL is here. That's a big deal. We now have two pairs of corresponding sides that are congruent. Sweet. We're only missing one piece of this puzzle. We need to either show, let's see, side. We need to show that this line here is congruent to itself. We need to show that this J and K are congruent angles. Let's see, angle, side, angle. We can't really use that because we already have two sides, so don't mess with that. This one only has one side, so it's going to be one of these first two. And we don't know anything about any of the angles, so it must be side. But how? Well, for this one, this line XL is actually a line on both of the triangles. It's a line on this triangle, the one on the right, and the one on the left. So if you're using the same line in both, they're sharing the same line, it must be congruent to itself, right? So the way that we mark that in the picture is we kind of make a little X like this, saying, hey, this line is congruent to itself, and we're using that fact. So now we have three pairs, 1, 2, 3 pairs of corresponding sides that are congruent to one another, and we can definitely show that triangle JXL is congruent to triangle KXL. We just need to write it up. We've done the hard work. We've done the heavy lifting. We just need to pick up the pieces now. So here we go, statements. The first statement I'm going to write is this given statement. X is the midpoint of JK. X is the midpoint of JK. How do we know that? Well, it's given to us. We didn't do any work to get that one. It was just handed to us. Sweet. Statement 2. Let's build on what we have here. We made a big discovery based on this one given piece of information. We learned that JX and KX were congruent to one another because of this fact. And this fact told us that this is the midpoint, so it's going to chop that line in half. So by the definition of midpoints, we know that X is exactly in the middle, which creates two corresponding segments. So the way that I would capture all of that information as concise as possible, I would say that JX is congruent to KX. And the reason that we know that that's true is because of the definition of midpoint. So we took our original fact and we built on it. So we're given that it's the midpoint. Cool. Let's now use that definition of midpoint to make our next make our next point. Okay, statement 3. We have another piece of given information. JL is congruent to KL. Let's capture it. JL congruent to KL. Make sure those lines go on top. When we're talking the length of these things, you don't need the line, but we're talking about the lines themselves. So 3, we know this because, again, it is given. We didn't have to do any math for that. It was just handed to us. Sweet. Okay, statement 4, this is the kind of the weird one. This is where we have to describe why side XL for this triangle is the same length or is congruent to side XL for the triangle on the left. So the statement's going to look goofy, and a lot of times students forget to write this step because it seems like common sense. I agree that it's common sense. It still needs to be written. Super important. So we're going to say, let's do alphabetical. I'll do LX. So LX is congruent to LX. Again, you're saying that one thing is congruent to itself. Duh, but it still needs to be stated. And the reason that this is true, we call it the reflexive property. Reflexive property. All right. We have demonstrated, we've proved that this pair of triangles has 1, 2, 3 pairs of corresponding sides that are congruent to one another. We're ready to wrap this up. Because it has 3 pairs of corresponding sides that are congruent, we can definitely say, because of the side criterion, that these two triangles are congruent. So our final step here is going to be our prove statement. So triangle JXL is congruent to triangle KXL. And why is that the case? We can simply say side, 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 or just S, S, S. There we go. That's one proof down. We're going to do just one more. Okay, here's our second and final proof of the day. We have this figure. It looks kind of like figure 8-ish. We have triangle GHK and triangle LHJ, and we are trying to demonstrate that they are congruent to one another. GKH and JLH. Boom. Okay, we're given a few pieces of information. Again, let's draw on our picture as we go. Let's craft a plan, and then we'll go over there to our table and try to rate this thing all up. So, given information, angle K and angle L are congruent to one another. L and K have the same angle measure. Don't know what it is. Don't care. Just know it's the same. What else do we know? We know that KH and LH are congruent sides. So KH, boom, and LH, bang, are congruent sides. Cool. Well, now we have two pieces of information. We have two pairs, or two parts of both triangles, two corresponding parts of both triangles that are congruent. We don't yet have a third. So here we need to put on our thinking caps a little bit. There's something that's hidden in here a little bit. What's hidden in here is this pair of vertical angles. We have two lines that are crossing each other, two straight lines, and so right where they intersect creates two corresponding angles, which we know are congruent to one another. So I'm going to mark that with this double angle marker here, distinguishing it from the others. So the one with the singles, that's a congruent pair, and the doubles, that's a congruent pair as well. Well, now it looks like we have angle and a side and an angle, and then up here we have an angle, a side, and an angle. That looks pretty good to me. Let's confirm it's on our list. There it is, angle, side, angle. That's the one we're going to utilize. So when we go over to our proof, we're going to put both pieces of given information down. Here's step one, here's step two. I think step three, all we need to do is say that these two angles are congruent to one another because of vertical angles. Step four is just going to be our proof statement. Boom, easy peasy. Let's do this. So the first one, we're going to say angle K is congruent to angle L. So it looks like angle, angle. It's angle K, angle sign, letter K, congruent to angle sign, letter L. And we know that because it was given. Step two, let's talk about our other piece of given information. KH, so side KH is congruent to LH. And we also know that, again, because it's given. Step three. This is where we're going to talk about our vertical angles, our pair of vertical angles. And we have to be careful how we name them. I think that's the trickiest part of this whole thing. We can't just say angle H is congruent to angle H because there really are four angle H's. Because H is this vertex, we could be talking about this angle up here, the one on the bottom, the one on the left, the one on the right. We need to be specific, so we're going to name it using our three letters that we've done. It's been a minute, but it's things we've done in the past. So we have angle KHG and angle LHJ. That's how we're going to name these things. So angle KHG is congruent to angle LHJ. The key thing here is that the vertex, in this case it's H, is in the middle of both of these. We could have written these backwards. This could have been angle JHL, and this could have been angle GHK. It doesn't matter, it means the same thing. The key thing is that the vertex is the one smack in the middle. Okay, how do we know that this is true? Vertical angles are congruent. Vertical angles are congruent. So now we have an angle, a side, and an angle. We've demonstrated that we have an angle, a side, and an angle that are all congruent parts. Corresponding parts that are congruent, I should say. So we can wrap this thing up. Step four. We are going to say, we're just going to write our proof statement now, that triangle GKH is congruent to triangle, whatever we name the other one, JLH. And the reason that we know that this is true is because of the angle, side, angle criterion. So we can just write angle, side, angle, and I'm happy with that. Boom, we're given this figure, we're given a few pieces of information, and we're given a tall task of proving that these two triangles are congruent. We did it. There it is. Okay, you have a few proofs for this assignment. Give them your best shot. Let me know if you have questions, and I believe in you. You got this.